Hello, welcome back to Mastering Statistics. We're going to solve another problem in hypothesis testing that involved two variances, and it'll be a left-tail test as we've done in the previous section. So this problem is talking about a golfer. He thinks that the variance in the distance traveled by golf ball brand A is smaller when you hit it than when you compare it to golf ball brand B. So to test this out for the whole population, he samples and he swings at 10 golf balls from brand A, and he finds the sample variance is 201.65. He then hits 10 different balls from brand B, and he finds the sample variance to be 364.57. So he's going to use a 0.05 level of significance, which corresponds, you should know by now, to 95% level of confidence. And he's trying to figure out, does the evidence support his claim? So basically you have two balls, brand A, brand B, and he just thinks that brand A is more consistent. That means that when you hit the balls, they have a certain average distance they're going to travel, but it looks like the variance, at least from the data he collected, is smaller when you hit brand A. That means that the place where the ball lands, it has smaller variability in other smaller areas where they seem to hit, whereas golf ball brand B is all over the place because the variance in the distance traveled, even when you hit them all the same, is much wider. So brand B looks to be a little more inconsistent. Brand A looks to be a little more consistent. So we're trying to figure out if this is enough data at 95% to draw a conclusion about the whole population of brand A and brand B. So the first step is to write down the data that we have. So we have brand A, and I really encourage you to do that. Brand A. And for the purposes of our discussion here, we're going to call this brand number 1. We're going to call it brand 1 and brand 2, brand A, brand B, because when we write our equations, we always have 1s and 2s. And we collected our data, so we say we sample n sub 1 is 10. We sample 10 golf balls, and the variance in the distance that they travel is 201.65. And then we're going to go over here and call brand B, which we're going to actually call it 2 as we write our equations here. We sample, again, 10 balls. N sub 2 is equal to 10. So we'll go back here, equal to 10. And then S2 squared, the variance in the second brand golf balls, is 364.57. Okay, 364.57. So it looks at first glance that the evidence does support the claim, right? If I saw this data, I'd say, well, this does look smaller than this. It looks like the variance is smaller, case closed. But in statistics, we don't care about the 10 samples. We're trying to draw conclusions about the millions of golf balls coming off of brand A and brand B. It's because maybe I am a competitor. I want to know maybe how I'm comparing. I want to know what my whole plant is doing. So I'm sampling 10 balls. I'm trying to figure out if this is enough information to draw a conclusion about all of the balls coming out of each of these factories. So the next step here is to write down the claim. The claim is written basically right here. A golfer feels the variance in distance traveled brand A is smaller than brand B. So the way you need to write that down, or the way I encourage you to write that down, is to write the word claim. And whenever you do that, the alternate hypothesis is always the claim. So we're saying the variance in the golf ball number 1 compared to golf ball number 2 is less than. Now we start changing from S squared to sigma squared because this S squared is the variance in what we collected. The 10 samples we collected, we calculated the variance there. The hypothesis claim is the entire population of golf balls. We're trying to see if what our data has collected supports extrapolating and seeing if we understand that this is true for the whole population. So the sigma represents the variance of the distance traveled of the entire population of golf balls. Now, if that's the alternate hypothesis, the null hypothesis is the exact mathematical opposite. So you just write the same symbols down, the variance and distance traveled, and you have to switch the arrow and put an equal sign under it, because together both of these have to basically encompass all possibilities. Either brand A is smaller than brand B in the variance, or it's greater than or potentially equal to. So this is important to write down. You have to write that down. And then the next thing you also want to write down is that the level of significance for this problem is 0.05, which you should know again by now is 95% level of confidence. All right, so we essentially need to, at this point, what I always encourage you to do is draw a picture. When you get the data written down, you need to figure out, first of all, is it a left-hand test or a right-hand test? We write the alternate hypothesis down, and it has a left-hand arrow. This left-hand arrow in the alternate hypothesis means that it's a left-hand test. So it's bulletproof. You just write it down, is exactly